Hey everyone, welcome back to Shah Byte. My name is Shah, and in today's video, we are going to talk about a $7 app on Steam that claims to double your frame rate. You have probably heard the talk. Some call it a game changer for budget PCs, others call it a gimmick that adds input lag. The truth is, it is one of the most powerful and misunderstood tools in the PC gaming arsenal, but using it wrong will give you a terrible experience. Using it right can feel like a hardware upgrade. This isn't just another surface level review, this is the A to Z Masterclass. We are going to discuss this topic together, so grab a drink, settle in. There will be no nonsense here. This is the guide that empowers you, especially those of you with older or mid-range hardware. I have a clear plan, and I will guide you through this one step at a time. We'll start with the mandatory golden rules, then I'll walk you through the core workflows, the frame generation workflow, and upscaling workflow. After that, we'll go under the hood to fine-tune the advanced rendering and capture settings for absolute control. We will integrate everything to create the legendary combo. We'll uncover the expert multi-GPU offloading hacks, including the simple trick that gives laptop users a massive advantage by transforming their iGPU into a dedicated frame generation chip, and the more advanced setups for desktop users willing to get their hands dirty. And just because we can, I'll show you how this tool's power extends beyond gaming, from upscaling and frame generating your old local video files to turning any web video into a battery-smooth experience. And finally, the real talk. The honest, unfiltered verdict. We will look at the artifacts, we will talk about the input lag, and I will tell you exactly who should buy this and who shouldn't. No fluff, no myths, just data and demonstration, because the facts are powerful enough on their own. Let the show begin. Alright, let's kick things off with the fundamentals. The tool is called Lossless Scaling. You can only get it officially from one place, Steam, and it costs about $7. So what is it? Lossless Scaling does two very powerful things for any game on almost any graphics card. First, it's an upscaler. It lets you run a game at a lower, faster resolution, and then intelligently scales the image up to your monitor's native resolution, making it look sharp and clean. You get the high FPS of a low resolution, but with much better image quality. Second, and more importantly, it's a frame generator. It uses AI to look at the real frames your GPU renders, and then it creates and injects new synthetic fake frames in between them. This can double or even triple your final frame rate, creating an incredible sense of visual smoothness. Now, let's be absolutely clear, Lossless Scaling is a one-size-fits-all tool that is not designed to replace native in-game solutions like DLSS or FSR. If a game has those, they will give you better results. Lossless Scaling is a universal tool for every other situation. For older games that don't have these features, for emulators, for hardware that doesn't support them, or even for modern games that are stuck with a very old, blurry version of FSR or DLSS. In those cases, this modern tool can actually give you a better picture. It's the cost-efficient alternative for when no good alternative exists. Before we even open the application, there are 3 golden rules. These are non-negotiable. If you skip this, you will have a bad time. Rule number 1. Your game must run in a windowed mode. Lossless Scaling cannot hook into a game running in exclusive full screen. Lossless Scaling works by capturing the game's window output. Exclusive full screen mode gives the game direct control of the display and blocks external apps like this from hooking in. It simply will not work. You need to go into your game's setting and choose windowed, borderless, or windowed full screen. Some games are more stable with one over the other, so if borderless doesn't work, try a standard windowed mode. Rule number 2. For fixed frame generation, you must cap your base frame rate. Think of the AI like a factory assembly line. It needs parts delivered at a steady, predictable pace. The frame generation AI needs a consistent, predictable stream of frames to do its job properly. A fluctuating frame rate is like someone just throwing parts at it randomly. Here's the pro strategy. Run your game natively and watch your frame rate. If it bounces between 45 and 60, your lowest stable point is 45. But here's the expert level detail most guides miss. Activating frame generation itself uses GPU power. The moment you turn it on, your base FPS will actually drop by 10% to 30%. Therefore, if your lowest stable point is 45 FPS natively, you should cap it even lower to leave that essential headroom for the AI. This gives the AI a rock-solid input, which translates to a perfectly smooth output. You will need an external tool for this, like RivaTuner, which comes with MSI Afterburner, or your GPU's control panel. As a rule of thumb, the developer recommends a base of at least 30 FPS for 1080p and 40 FPS for 1440p. Any lower and you are generating junk. Rule number 3. Disable other overlays. This is a troubleshooting step. The LSFG feature does not play well with other applications trying to draw on top of your game. You must ensure that overlays from applications like Steam, Discord, NVIDIA Overlay, or the Xbox Game Bar are turned off. They are known to interfere with the output and can prevent frame generation from working correctly. With the laws laid down, let's optimize. Here's the main interface. It looks complex, but it is logical. On the left are your game profiles, and in the center are all your settings. The developer included helpful tooltips. Just hover over anything to get a detailed explanation. We are going to configure our general settings first. Click the gear icon. First, set a memorable scale hotkey. This is how you will turn the magic on and off in-game. I use Ctrl-Alt-S, but use whatever works for you. Now back on the main screen. Under preferred GPU, if this is set to auto, it will almost certainly default your weak integrated CPU graphics, giving you a terrible performance. You must change this to your dedicated graphics card, your NVIDIA or AMD. Next, profiles. You can click plus icon to create and save different configurations. This is incredibly useful. You can have one profile for upscaling old games and another for frame generating new ones. You can even link a profile to a game's executable file and set it to auto-scale, so it applies your settings automatically when you launch the game. Let's look at the cursor settings. These are all user preference. Clip cursor stops your mouse from leaving the game window. When you upscale from a lower resolution, your mouse feels faster. This option compensates for that to keep your muscle memory intact. Height cursor does what it says, pure preference. A scale cursor makes the cursor icon look bigger, along with the upscaled image, which can be useful to stop it from looking tiny. Foundation is set. Now for the fun part. Okay, workflow 1. Our goal is simple, pure smoothness. We are running our game at native resolution and just want to double our frame rate. So the first thing we do is go to the scaling section and set the scaling type to off. We are not using it. Now, let's focus on the frame generation panel. Type selects the frame generation algorithm. Always select the latest LSFG version available. Right now, that's LSFG 3.1. It's not just a new number. This update brought significant architectural improvements. The developer specifically focused on refining UI detection to fix issues like crosshair ghosting and on reducing overall ghosting and flickering. You want these quality of life improvements. You can select older versions too, but there is no strategic reason to do so. And off simply disables the feature entirely. Mode determines how frames are generated. We are choosing fixed. This applies a simple, direct multiplier to our base frame rate. If we capped our game at 40 FPS, a 2x multiplier will give us a locked 80 FPS. It offers the best quality as long as your base FPS is stable, which we ensured with our golden rule. The other option is adaptive. You would use this if your base frame rate was unstable or uncapped. You give it a target FPS and it will dynamically insert frames to try and hit that target. Now, here's the technical detail you need to understand. To hit a specific target, adaptive mode has to use fractional multipliers, and the key takeaway is that these fractional multipliers are more computationally expensive. Forcing a 1.8x multiplier to hit exactly 80 FPS can actually use more GPU power than just using a clean 2x multiplier in fixed mode. So the trade-off with adaptive isn't just responsiveness, it can also be a higher performance cost to achieve that perfectly locked frame rate. For multiplier, we are starting with 2. This will double our frame rate and is the most stable and reliable option for fixed mode. You can go up to 20x, but anything above 3x in fixed mode introduces severe artifacts and is not practical. To use 3x or 4x effectively, you really need a base frame rate of 60 FPS or higher. Lossless slider controls the internal resolution the AI uses for its calculations. Higher means more data and a smoother motion and fewer artifacts. For a 1080p display with a decent GPU, set this to 100% for maximum quality. If you are playing at 1440p or 4K, there are so many pixels that you don't need 100%. At higher resolution, there are enough pixels that the AI can get great results with less data. The developer recommends 50% for 4K and 75% for 1440p. This will reduce the GPU load. You can also lower this if your GPU is struggling as an alternative to using performance mode. But we are turning the performance toggle to on. It enables a faster algorithm that lowers the GPU load and can reduce latency. Now, this is important. The tooltip says this has a slightly worse quality. Some deep dive analyses have shown that performance mode can cause a noticeable quality drop on small UI elements, like crosshair. Other experts say you will never notice it in motion, and the latency benefit is a no-brainer. Here's my take. Turn it on. But if your crosshair starts looking funky, you know what to blame. Try turning this off and lower the flow scale instead. Now, a point about measuring your results. You cannot use RivaTuner, the NVIDIA overlay, or any other third-party FPS counter to see your final generated frame rate. Those tools read data from the game engine before Lossless Scaling injects the new frames. To see the real number, you must use the application built-in tool. Go to the rendering tab and toggle Draw FPS to on. That's it for frame generation. Now, our second workflow. Now, for our second workflow, our goal is to get more raw FPS by rendering our game at a lower resolution, but without it looking like a blurry mess. A critical point here, which is the exact opposite of our frame generation rule, you must uncap your frame rate, disable VSync, remove any external frame limiter. The entire point of upscaling is to see how high your performance can go, so we need to let the engine run as fast as it possibly can. For this technique, we'll turn frame generation off and focus entirely on the scaling panel. A scaling type selects the upscaling algorithm. The right choice depends entirely on your content. For modern 3D games, AMD's FSR is an excellent choice. It provides a great balance of quality and performance. You have many options here, and the right one depends on your content. LS1 and NVIDIA image scaling are also great for 3D games. If you are playing a pixel art game, you want XBR. And for cartoons or anime, there is a dedicated anime 4K algorithm. For a scaling mode, here's the pro tip. Set the first drop down to custom. This is the key. It unlocks the factor setting, allowing us to dial in a precise upscale. Auto is simpler. It automatically calculates the factor needed to make your windowed game fill the screen. But by choosing auto over custom, you lose the control that custom provides. The second drop-down has an aspect ratio option, which you would use if you want to prevent the image from stretching, which may result in black bars. Now, because we choose custom mode, we can now input a value here. The factor corresponds directly to FSR presets. We will use 1.5. This is equivalent to FSR quality preset. a fantastic balance of image quality and performance boost. 1.3 is ultra quality, more sharpness, less performance. 1.7 is balanced, more performance, a slightly softer image. And 2.0 is performance, maximum FPS boost, but the softest image. You will also have to enable the resize before scaling toggle. This is critical for making this custom factor method work correctly. Sharpness is pure user preference. The default is 1, adjust it until the image looks right to you. Setting it too high can create ugly white outlines around objects. Now you know how to configure both core technologies, but what happens when we combine them? This chapter contains the advanced tuning knobs. Let's demystify this stuff so you can use it, not to be afraid of it. Capture API controls how lossless scaling grabs the game's image. It's simple. If you're on Windows 11 24H2 or newer, use WGC. It has lower latency, your cursor will feel much smoother, and it is easier to record with OBS. For everyone else, I mean older Windows 11 builds or Windows 10, you should stick with DXGI. It's the most compatible option and works best for frame generation on those systems. Q target is your latency versus a stability knob. It controls how many frames are buffered. 1 is the sweet spot. It adds 1 buffer frame, which makes things way smoother for a tiny, basically unnoticeable latency cost. 0 is ultra low latency mode, but it can be less stable. And 2 is heavy load compensation. Use it only if your GPU is at 100% load and you are experiencing inconsistent frame delivery. It adds the most latency, but can smooth things out. For sync mode, if you have a G-Sync or FreeSync monitor, set this to off. Let your monitor do the work. This is the lowest latency option. But if you don't have a VRR display and the tearing is driving you crazy, you can try default or resync, but be aware, this will add some input lag. Now, here's a secret for max frame latency. For NVIDIA cards, set this to 1. For AMD cards, set this to 3. This helps ensure the lowest possible input latency for your hardware. And those HDR and G-Sync support toggles, only turn this on if you have that specific hardware and you are experiencing color or stuttering issues. They are compatibility fixes, not general enhancements. Alright, time to put it all together. This is the grand final, the secret recipe that combines everything we have learned for the best possible result. Here's the logic. This is a multi-stage operation. First, we use upscaling to build a new high-performance foundation. Then, we calibrate that new baseline. And only then, we multiply it with frame generation. Step 1. Build the upscaled foundation. First, go into your game and set it to a low windowed resolution. For example, on a 1440p monitor, drop it to 1080p, or on 1080p, something like HD. This will reduce the load on your GPU. Next, go into lossless scaling. For now, turn frame generation off. We are only focusing on the upscaler. Configure your upscaling settings as we did in the second workflow. A scaling type to FSR, mode to custom, factor to 1.5 for quality, and enable resize before scaling. A critical point before you activate anything, make sure any existing frame limiter, like in RTSS or your GPU driver, is completely disabled. The goal here is to find the true performance of the upscaler, and an existing cap will give you a false reading. We need to let it run uncapped. Now activate lossless scaling. Your game is now running upscaled, and you should see a frame rate boost. Step 2. Calibrate the new baseline. This next step is critical. With the upscaler running, this is your new true base performance. Play the game for a minute and find your stable frame rate. Now we apply the pro strategy. Deactivating lossless scaling, go to RTSS and cap your frame rate below that new upscaled number. Step 3. Stack frame generation. With your new stable cap in place, go back into lossless scaling. Your upscaling settings are still there. Now, Simply configure your frame generation settings from the first workflow on top of it. Type to the latest LSFG, mode to fixed, and multiplier to 2x. Now, when we press our hotkey, the software takes our high-performance signal, upscale it to a sharp native image, and then doubles the already high frame rate. This is how you can turn a struggle into a buttery smooth experience. This is the secret sauce. Now for an advanced technique that is an absolute game changer, especially for laptop users. We are going to offload the entire frame generation workload to your secondary GPU or your CPU's integrated graphics, leaving your powerful primary GPU 100% free to just render the game. This is how you get free performance without the usual overhead. See, laptops have a hardware layout where the built-in screen is physically wired to CPU's integrated graphics, the iGPU. We can exploit this. We can offload the entire frame generation job onto that iGPU, which is just sitting there doing nothing while you game. This lets your real GPU focus 100% on rendering the game, giving you the highest possible base FPS to work with. For laptop users, this is simple. At first, I must say, this trick only works when you are using the laptop's internal display. If you plug in an external monitor, it will almost always bypass the iGPU and this technique will fail. The process is incredibly simple. At first, make sure you are not using an external monitor. After that, in Lossless Scaling, go to Preferred GPU and change this setting from your dedicated NVIDIA or AMD card to your integrated graphics. That's it, you're done. Your dedicated GPU renders, your iGPU handles the frame generation. It's free performance from hardware you already own. Now for desktop users, this is also possible, but it's a much more involved process that I can't demonstrate, as I don't have a desktop PC for testing. But I will give you the exact blueprint based on my research. There are two methods. Method 1 is dedicated GPU with iGPU offloading, and method 2 is dedicated GPU with dedicated GPU offloading, or dual GPU offloading. Method 1 uses the integrated graphics on your CPU, which is likely sitting completely unused. Step 1. You must physically unplug your monitor display cable from your powerful graphics card and plug it directly into the HDMI or display port on your monitor's I/O shield. The final video signal must come from the iGPU for this to work. Step 2. This is where it gets tricky. By default, most motherboards automatically disable the iGPU when a dedicated graphics card is detected. You have to override this. Reboot your PC and enter the BIOS. You need to find the graphics configuration settings. Look for options like Primary Display, Initiate Graphic Adapter, or iGPU Multi-Monitor, and set the primary output to Integrated Graphics or iGPU. Every BIOS is different, but this isn't just a simple headache of finding a menu option. We are talking about a process so finicky that it can easily result in your PC failing to boot at all. Expert troubleshooting has shown that you might need to try extreme measures just to get the system to post things, like physically removing your main graphics card, booting with only the iGPU to change the BIOS setting, then shutting down and reinstalling your card. This requires a deep level of patience and a willingness to troubleshoot a machine that won't turn on. Step 3. Before you go any further, open Task Manager and go to the Performance tab. You must see two GPUs listed, your dedicated card and your integrated graphics. If you only see one, the BIOS setting is wrong and you need to go back. Step 4. Once both GPUs are active, go into Windows Settings, find the Lossless Scaling executable file and assign it to power saving to force it onto the iGPU. Then, inside Lossless Scaling itself, set the preferred GPU to your iGPU. Method 2 uses a second dedicated graphics card to handle the frame generation workload. Now, before we get into the hardware, let's be clear, this isn't SLI or Crossfire. Forget all that. There are no physical bridges, no special driver requirements, and it doesn't need game-specific support. This is a universal software-level trick that leverages the second graphics card as a dedicated frame generation chip. Step 1. Install your second, weaker GPU in another PCIe slot. Then, just like the iGPU method, you must plug your monitor into the secondary GPU. The final, processed signal comes from the card doing the frame generation, not the one rendering the game. And be aware of your hardware's limit. An ancient secondary card can become a bottleneck and hurt performance. Step 2. Go into Windows Graphics Settings, find your game's executable file, and manually assign it to your primary high-performance GPU. This is critical. You are forcing the heavy rendering work onto your main card, while Windows uses the secondary card for the display output and other tasks. Step 3. In Lossless Scaling, set the preferred GPU to your secondary, weaker GPU. This tells the application which card to use for its calculations. Be very careful running mixed AMD and NVIDIA cards in the same system. While it can work, it might cause instability. Both methods are for those who really want to get their hands dirty, but they can completely eliminate the performance penalty of frame generation. This tool's utility doesn't end with gaming. You can apply these same principles to any video content, local or web. Let's say you have an old video file. You can open it in a media player and use lossless scaling to make it sharper. The key is choosing the right scaling type for your content. For anime and cartoons, use the Anime 4K algorithm. It's specifically trained for it. For live-action movies and TV shows, treat them like a 3D game. Use FSR or LS1. If you have old pixelated video, XBR can do a great job. Second, and even more powerfully, you can frame generate any video. This works for local files in a media player and for any video in your web browser, like on YouTube or Netflix. The process is simple. In Lossless Scaling, set the scaling to off and configure frame generation to fixed with a 2x multiplier. This transforms any standard video into a high frame rate experience. It's an incredible bonus feature that adds a ton of value to this software. We have seen the magic. Now, for the dose of reality, let's talk about the trade-offs, because they are real. First, input latency. This is the biggest catch. The game will look buttery smooth, but it will feel less responsive. It's a disconnected feeling. And if your base frame rate is too low, the input lag will make the game completely unplayable. Next, visual artifacts. The AI is smart, but it's not perfect. It has to guess the motion without any data from the game engine itself, and sometimes it guesses wrong. Watch the crosshair here. You can see it ghosting and shimmering during fast movements. Static UI elements are usually fine, but moving elements can get messy. The latest updates have improved this, but not eliminated. And also, the algorithm can get confused by complex, repeating patterns. Things like stairs or stripe patterns can appear to warp as you move past them. The latest updates have also improved this, but not eliminated. It is crucial to remember that native solutions like DLSS and FSR are generally better at avoiding these issues, because developers integrate them directly into the game engine. Lossless Scaling is doing its best from the outside, and these artifacts are the price you pay for its universal compatibility. But here's the thing, you have to give massive credit for the developer here. A solo dev who is consistently pushing updates. The frame generation algorithm has seen huge improvements in quality and performance since it was first released, and it keeps getting better. That brings us to the final question. After all this, should you spend that $7? That wraps up our guide, and my answer depends entirely on who you are. I have broken it down into two profiles. First, the competitive player. You play Valorant, Counter-Strike, Apex Legends. For you, the answer is no. Avoid this. Your entire game depends on low input latency. The lag from frame generation is a direct handicap. You are always better off just lowering your in-game settings for more real frames. Second, the casual and story-driven player. You play single-player RPGs, strategy games, simulators, or you are on a budget rig trying to get the latest AAA title to just run smoothly. For you, this is an absolute must-have. The visual smoothness is a total game changer, and the input lag is far less of a problem in these games. It will breathe a new life into an aging GPU. If this masterclass helped you, a sub to the channel is always appreciated. By the way, Lossless Scaling gave us universal frame generation. What if you could perform surgery on a game, rip out its outdated FSR or even its native DLSS and transplant the absolute latest tech in its place? That's a new mod called Upscaler. It claimed to do just that. The next video is a deep dive. We are going to verify the claims and find out if this is a true game changer or just another complicated mess. That's the philosophy of this channel, cutting through the noise to find what actually works. We'll be covering everything from deep dive software guides like this one to PC customization, performance optimization, and even privacy and security. The goal is to give you verified, data-driven guides to make your entire PC experience better. Stick around if that sounds good to you. Peace out.